I'm going to talk you through how you can install Harmony and get started working with Harmony in Python on your computer. So you can find instructions on our GitHub repository at github.com/harmonydata/harmony. The first thing we want to install is Python. I recommend Anaconda Python. By the way, I'm running Linux, Ubuntu, but the process would be similar on Windows or a Mac. I go to anaconda.com and I can download Anaconda. This takes a while. So now Anaconda has been downloaded to my computer. So I just need to install it. I launch a terminal or a command line window and I go to my downloads folder and I find the downloaded file and I can run it. Now I'll be asked to accept all the conditions, so I just type yes, press enter, and go through all the steps of the installation process. And I accept the default install location. And now Anaconda is installing. This part takes a few minutes. Now Anaconda is installed. So to run it, I need to just open a new terminal window and type Python, and I'll be able to run Python. So we're on version 3.11. That's good. That's more than enough to run Harmony. Now the command is pip install harmonydata. You don't need to go to any website. You can just install using pip, which is the commonest Python installer for Python libraries. And we can see that Harmony is installing all its dependencies as well, which is great. So this part takes a while as well. The next thing I'm going to do is I'm going to install Tika. So Tika is a library used by Harmony to parse PDFs. So I have to go to tika.apache.org and find the download of Tika. So I'm going to download Tika version 2.8.0, but really you could use almost any version. And I will get a jar file. I also need to download Java in order to run Tika. So I'm downloading the Tika server. And in the meantime, Harmony has finished installing, but I still need Tika, which runs in Java. The other thing we need to do is we need to install Java. So let's open a new window. And in Ubuntu, this is how we install Java. We just write sudo apt get update to get all the most recent packages, type in our password, and then we run the apt get install default JRE, which would be the default Java that comes with Ubuntu. If you're on Windows or Mac, you can Google for install Java and you can download Java from Oracle's website. So now Java is downloading. So to recap, we need Python, we need Java, we need Tika, and then we need Harmony. So 4 things. So this would be where you'd install Java from a Windows computer, for example. So now Java should be installed. So now we have Tika downloaded, and Tika has been downloaded into my downloads folder, so I can run Tika. So I type java-jar Tika server, and then you can see Tika's running there. Now I like to work in Jupyter Notebook, so that's the other reason for installing Anaconda. Anaconda comes with Jupyter Notebook out of the box. It's a really nice environment to do experiments in, and it lets you type commands and then view the result or the graph that comes out of it underneath what you've typed. So it's really nice. The equivalent in R is RStudio. So we make a new notebook, we rename it Harmony Project 1, and we can import Harmony. So Harmony is downloading the sentence transformer models, which are the neural networks which Harmony uses to represent text as vectors. By default, Harmony uses a multilingual transformer neural network which can represent English or Spanish or Portuguese text as vectors. However, you can switch this around and get Harmony to use any kind of sentence transformer, including even GPT 3.5 or GPT 4. If you just connect it up, you can also make Harmony use a monolingual sentence transformer. There's a blog post on our website where I've used Harmony to process text in Shona, which is a language spoken in Zimbabwe, and I used a Shona only sentence transformer model for that. So any transformer model is possible, any kind of vector representation is possible. So Harmony's, you can see Harmony's downloading these transformer models. They're pretty huge models, and they take up a lot of space on your disk. They're being downloaded from Hugging Face's website by default, which is what we're using as our machine learning library inside Harmony. But like I said, you can switch this out and use something else. So now everything's been downloaded. The next thing I have to do is to download Harmony's models that it uses for text extraction. So that is for extracting unstructured text data from PDFs of psychology questionnaires. So we can do that with harmony.download_models, and Harmony is downloading the spacey models from our server. Now Harmony's models have been downloaded and they are saved in our home directory. If I open my file browser and have a look, I can see that there's a new folder called Harmony, which has this folder Harmony Spacey Models. Now we should be able to use Harmony to match some instruments. So first we can try and get some example instruments. So these are the instruments that come in your Harmony installation. Let's try this. From Harmony, import example_instruments. You can see if I'm not sure, I can just type EX, press tab, and I get the autocomplete. And let's see what the example instruments are. So let's take one of them and see, okay, well, let's see what instruments are present. So example instruments.keys, it's a Python dictionary, and we can see we've got SESD English, SCARED English, GAD7, De Jong Geerveld, so a number of different instruments. Let's use the Python square brackets and we can get the SESD. Okay, so I'm going to put that in my instrument one, SESD. Let's call this one SESD. That's a variable. Okay, now let's take another one, GAD7 English, for example. And I do the same process. I retrieve the instrument from my dictionary and I store it in a variable called GAD7. Now we've got GAD_7 and SES_D, two variables. We can just ask Harmony to match them. So Harmony will use its neural network to match them. So we import the match instruments function from Harmony. You can see there's this other match instruments with function, which allows you to use your own custom function for matching, such as OpenAI or Google Bard or whatever you like. But we're just going to use the default matcher. The matcher returns 4 arguments, which are the questions that it matched, the similarity matrix, the query similarity, and a vector dictionary, which we can ignore for now. So we can call the matcher and send it our 2 instruments, the SESD and the GAD7, and let's see what it does. So I press Shift and Enter and I run it. And what have I got? Let's have a look at the similarity matrix. We've got a huge matrix of cosine values, which gives us the similarities between the different items in the GAD7 and SESD. So the row and the column of each part will tell you what is being matched to what. And you can see on the diagonals of our matrix, we've got 1s, which is obvious because an item matched with itself is 100% similar. Let's try and do something a bit more interesting. Let's find the GAD7 in French. So I haven't tried this. This is the first time I'm trying it. Let's download a PDF of the GAD7 in French. So I'm going to save this to my computer and copy the file name. So let's now see if we can get Harmony to parse this. So we're going to create a new variable, GAD_7_French, and now we have to import something from Harmony, which is the function to load instruments from a file on our computer. So from Harmony, import load instruments from local file. Now we create a new variable, GAD7French, and simply pass it the local file name. So it's in my downloads folder, gad7francais.pdf. And we can do Shift Enter again. And you can see in the output that Harmony has actually called Tika, and it has extracted some questions. You can see it wasn't entirely sure about one of the questions, so it looks like it's only got 6 of the 7 GAD7 questions, but that's still a start. So now here's our instrument, and you can see that it's represented in it can be represented in a kind of JSON format, and there's a lot of metadata about the instrument, and then there are the questions themselves. And so you can see the question text there. So now I can match my GAD7 in French to something else. So let's see what we get if we match it to the English one. So let's have a look at the question text first. So if I loop over all the questions in my GAD7 French, I can print the text, and we can see actually, okay, unfortunately, it only got 6 of the 7, which isn't bad. You know, it was an unstructured PDF that it's not seen before. So the question 4 was actually incorrectly excluded. However, overall, we have got the most of the question items from this instrument. Now let's pass the SESTI, the GAD7 in English and the GAD7 in French to Harmony's matching function again. And we get a similarity matrix, a little bit bigger this time. And if we take the last few entries of our similarity matrix, then I can walk over the last 6. So the last 6 entries correspond to the GAD7 entries in French. And we can see what did Harmony think that those GAD7 in French corresponded to, or were semantically most similar to. And like I said, I've not done this before. I've not even tried Harmony on French before, but we'll see how it does. So we're going to start at the end of the matrix, take away 6, and that would give us the final 6 elements. And so first I'm just printing the row, the nth row for the last 6 rows. Now let's have a look and see if we can get the maximum. So this is now the maximum similarity of those last 6. So it's saying the first GADS7 in French question 1 matched to the 28th question item that we passed to Harmony. GAD7 French question 2 matched to the 29th, and so on. And actually, yeah, I just realized we have to exclude the GAD7 in French from that. Otherwise, it's just giving us all the ones in the matrix, which are, trivial, is matching GAD7 in French to GAD7 in French. So if we exclude that, then we find GAD7 in French question 1 matches the 20th question in our list. GAD7 in 2 matches the 21st. GAD7 question 3 matches the 22nd. And then GAD7 question 4, the PDF extraction missed. GAD7 question 5 matches the 24th. So that sounds like it is actually matching the GAD7 French to the GAD7 in English, and it hasn't incorrectly matched anything to the SESTI. Of course, this is not a particularly difficult task because they're just translation. It's an official translation, but it's showing what Harmony can do out of the box. So let's see if we can get it to print the actual text of what it's matching rather than getting array indices. So we're going to print the text of the GAD7 in French question that that's we're looking at, and we will print the text of whatever it is that GAD7 French question matched, and we'll do an equal sign between them. So let's see how this print command works. And just need to get all the brackets in the right place. And now we run this, and look, we've got, this looks like it's a match. You know, this French text is the same meaning as feeling nervous, anxious, or on edge. I think it's matched them all correctly. Worrying too much about different things. Inquiétude excessive. Yeah, so it all looks like it's a match. That's great. Now let's take the index of the winning question, put that in a variable, and let's see if we can also print the match score, so the actual similarity which came out of that match, because that's going to be interesting too. So we'll retrieve the correct entry from that matrix, and look, we've got 89% match for GAD7 question 1 in French to question 1 in English, and so on. And the lowest match is this item 24, which is I believe the 5th GAD7 question, and that's got 63%. So, but overall, Harmony seems to work reasonably well doing this kind of match on major European languages. So we're using the Hugging Face transformer model, which has been trained on a large amount of text in several languages from the internet, but they are all very well-resourced languages. So if you want to use this on a smaller language or a language that's slightly less well-resourced, you should switch the transformer model. But overall, cross-language matching can be done.